In this video, we will be discussing frequency distributions, histograms, and measures of central tendency. All of these concepts come up in statistics. A statistic is a number derived from a set of data that is used to help describe or represent the data set. Suppose we had the following data set, which could represent homework scores on a scale of 1 to 5. Now this is a relatively small data set of only 12 data points, but now imagine if this had 100 data points. It would be fairly difficult to decide whether or not these homework grades represented a good set of homework or a bad set of homework. Was a 3 a common score? Was a 5 a common score? It would be hard to tell if there were 100 data points. So one of the first things we do with a data set is we create a table to represent this information called a frequency distribution. With a frequency distribution, you can list the possible values the data set can take, and then list the frequency of each of those values. For example, the number 1 shows up 3 times in this data set. It's also a common practice to represent the relative frequency of the data set, and this is the percentage of the total data set that value represents. For example, the number 1 shows up 3 times. There are 12 total data points, so 3/12 is 25% of the data set. Relative frequencies are nice because they translate across different sized data sets. For example, if I told somebody that 3 of my homework grades were 5 or better, if in their class they had a homework set of 50 homeworks, well then 3 wouldn't be very good. On the other hand, if I tell them that 25% of my homeworks were 5 or better, they could translate that to their homework set of 50 homeworks. Oftentimes it's nice to have a graphical representation of a frequency distribution. This graphical representation is called a histogram, or bar chart. And as you can see, the information in the frequency distribution is provided in this histogram. I can see that the value 1 shows up 3 times in the data set. 2 shows up twice, 3 shows up 4 times, 4 does not show up in the data set, and 5 shows up 3 times. A histogram is a quick way to give the information found in a frequency distribution. It's often easier for people to interpret graphs than it is for them to interpret large tables of data. For some data sets, instead of listing individual values in the frequency distribution, you'll want to list ranges of values. Consider, for example, grades on an exam, where the grades can range from 0 to 100, and imagine that there are only 30 students in the class. If you were to build a frequency distribution for this data set, it would most likely be filled with a lot of zeros, a few ones, and maybe the occasional 2 in terms of frequencies, because most students will receive different grades on the exam. A better idea would be to group the data and to list a value that ranges between 0 and 10 points, 10 and 20 points, 20 and 30 points, etc. Then you'll actually have an interesting frequency distribution and as well as an interesting histogram to go with it. An example of a frequency distribution with this grouped data can be found in your textbook. Once you have a frequency distribution and a histogram, you can make general observations about the data set. For example, with this data set given to us, I can easily say that 25% of the data is a 4 or greater. Or I could say that 25% of the data is a 1 or less. I could also say something like 75% of the data is between a 1 and 3. One of the common questions people have about a data set is what's happening on average. These measures are called measures of central tendency. One of the most common measures of central tendency is the mean. The mean of a data set is the average that most people would find if they were asked to find the average of a data set. The symbol that we'll use to represent the mean is x with a bar over it, and it can be found by adding up all of the x's and dividing by the total number of data points. So again here, n represents the total number of data points in your data set, and x is a variable that stands for each data point. And here again we see the summation symbol telling us to add them all up. In blue you can see how this formula would more traditionally be represented. Our data set would be assigned to x's. For example, x1 would be 1, our first data point, x2 would be 2, x3 would be 1, x4 would be 3, etc., representing our entire data set. then the mean of the data set can be found by adding up all the xi. The summation symbol often comes with indices. Here we're telling you to add from I equals 1 all the way to I equals n, and to add all of the xi. So we add x1, x2, x3, x4, all the way up to xn, where in this example n is 12 because there are 12 data points in the data set. The formula in black can be thought of as a shorthand version of this, where the summation symbol has no indices, therefore the reader assumes that we're to add all of the xi. Let's compute the mean of the data set in our previous example. According to our formula, the mean is found by adding up all of the x values and dividing by n, the total number of data points. Again, this is the average most people would compute if they were asked to find the average of these numbers. And this rounds to approximately 2.83. Now it turns out with the frequency distribution we could have saved ourselves a bit of work. We could have found the average by noting the following. The number 1 shows up 3 times, plus the number 2, which shows up twice, plus the number 3, which shows up 4 times, plus the number 4, which does not show up, plus the number 5, which shows up 3 times, and then divided that by 12. And again, we would have received the same answer of 2.83 as the mean of this data set. So frequency distribution can save you a lot of time when computing the mean. The next measure of central tendency we'll look at is the median. The median is the middle number of a data set. Suppose we have the following data set, 1, 3, 2. To find the median, first we must order the data set. So 1, 2, 3. Then the median would be the middle number of this data set. In this example, the middle number is 2. But what do we do if our data set has an even number of data points? For example, 1, 3, 2, 5. Again, we place the data in order, and then to find the median, we find the two numbers in the middle. In this example, it's the 2 and the 3. Then we take the mean of those two numbers. So 2 plus 3 divided by 2, 2.5 would be the median of this data set. Consider our previous data set. We could write these data points in order and again find the middle number to find the frequency of this data set. Now, in this example, there are 12 numbers, so we actually know that the median is going to be the average of two numbers. But now imagine that this data set had 100 data points, or 1,000 data points. It would be very tedious to list all of these data points in order and then try to find the center data point. Notice that when we had 3 data points, the number we chose was the second number. If you take 3 plus 1 divided by 2, you'll find that it was the second number we chose. When we had 4 data points, 4 plus 1 divided by 2 is equal to 2.5, so we averaged the second and third data point. In fact, in general, there's a formula which will tell you which points to average or which point to look at to find the median of a data set. This formula says that the location of the median can be found by taking n plus 1 divided by 2. Using this formula, we can use a frequency distribution to locate the median of a data set. Let's look at, for example, this frequency distribution that we have from the previous example. L is equal to 12 plus 1 divided by 2, which is equal to 6.5. This tells us that we need to find the 6th and 7th data point, and we're going to take the average of those two numbers, the mean of those two numbers, and that will be the median of our data set. So how do we find the 6th and 7th number? We do that by looking at the frequencies. We start with the value 1. It shows up 3 times, so numbers 1 through 3 will all be 1s. The next number would be a number 2, and that's our 4th number. And there are 2 2s, so 4 through 5 would all be 2s. The next data value would be a 3, and there's 4 of those. So numbers 6 through 9 would all be 3s. there are no 4s, and the last 3 numbers are 5s, so numbers 10 through 12 are all 5s. Now, to find the median of this data set, we need to find the 6th and 7th number and average them. The 6th and 7th number are both here, and both of these numbers are 3s. So we will average 3 and 3, which hopefully everyone recognizes the average of 3 and 3 is 3. So 3 would be the median of this data set. The last measure of central tendency that we'll be looking at is the mode. The mode is the most frequent data point or data points in a data set. So for example, consider the data set containing 1, 2, and 1. The mode of this data set is 1. Consider the data set 1, 2, 1, 3, 2. This data set is bimodal. It has 2 modes. The modes are 1 and 2, because both 1 and 2 are more frequent than any other number in the data set. When a data set has data values that are all equally frequent, we say that there is no mode, because no data value is more frequent than the rest. Most people can see the use for the mean and the median. The mean is the standard average that we're used to computing. And the median is another way to find the average, which will tell you if your data set has some form of consistency in the following sense. Look at the average income in the United States. If you compute the mean and then compute the median, you'll find that these two numbers don't agree. They're not even very close. That's because the mean income in the United States is brought up by a few very, very wealthy people in the United States. Whereas the median income tells you if you took everyone in the United States, lined them up by income, and found the person or persons standing in the middle, what would their income be? But when the mean and median do agree, you can say, even if they agree only within a small variance, you can say that this is a very good indicator of the average of this data set. But the common question is, when would we use the mode? Here's an example of a survey I'd given in class. I gave people the choices of 3 colors, blue, pink, and black, and I asked them to choose which of these 3 colors was their favorite. 9 people chose blue, 2 chose pink, and 10 chose black. Now suppose we wanted to do a statistical analysis of the average favorite color. So we're going to go ahead and assign some numbers to these colors. And let's suppose that we say that blue is 0, pink is 1, and black is 2. If we then compute the mean of this data set, you'll see that it's approximately 1.05. So 1. Well, the number 1 represents pink, so using the mean, we'd say on average pink is the favorite color of this class. Well, maybe we should check to see if the median agrees with the mean. Well, if you compute the median of this data set, you'll find that it's 1. Again, pink. So once again, the mean and median agree, so pink is clearly, on average, the favorite color in the classroom. But as you can see, that doesn't make much sense here. Only 2 people chose pink. The problem was that the data we were analyzing was not inherently numeric. We assigned numeric values to the different colors, blue, pink, and black, but those were done arbitrarily. But what we could have done is computed the mode. The mode of this data set is 2, so black. And yes, for these colors, if I had to give some indication of, on average, which is the favorite color, I would say black. It's liked by more individuals than any of the other colors.